Welcome back to the channel. Today we're going to give you guys a little bit more of a raw feel where I'm just going at it filming this 67 Nova. This project was brought to us and all the metalwork was already performed, and then we dealt with some different things throughout the process of getting the panels to fit that just weren't taken into account, like having the weather strip in the door and figuring out where the structure of the door actually needs to be. What you'll see here is that this door is almost touching the quarter panel. And then we have a big gap at the rocker. And I don't have the fender on the car at the moment, but I'm about to show you guys once we make a couple templates as to how big the gap is at the front. I know there's a lot of you guys on here gonna think, just move the door forward. But you can't, because somebody else has already put a skin on this door and the skin is not aligned with the actual structure of the door going into the opening of the jamb. So we are locked in, and this is the only area that this door can actually fit into the body of this car. So I'm going to take you guys through the process of how we fix a very extreme tight gap and a very extreme wide gap, and some of the different things you're going to struggle with, especially when it comes to welding the gap, because a lot of guys will just MIG weld the edge of the door. This particular project, we're going to show you how we TIG weld the door, why we TIG weld the door instead of MIG welding the door, and how you remove all of the warpage and panel dive after you have welded it. can see that we have the fender on, we have this really big 1/2 inch gap all the way down. But it does fit nice to the rocker. You can just see it's extremely wide there. And then right here we have it to where it's touching basically. And we've got to open up the back next. The bottom of the door is still a little on the wide side in areas. So we're gonna add to the front, we're gonna add to the bottom, and then we're gonna remove away from the back. When we do this, we're gonna have to build the inner flange and then TIG weld the entire edge to make it look like it was 100% factory that way. And then here, we have all of our panel alignment dialed in. Even panel alignment here is crucial because if this is off, this edge may end up thicker, and then when the door opens to the fender, all of your work will end up getting taken off. So you need to ensure that everything is flush, and I would recommend using a piece of flat 1/2 inch aluminum stock that goes the distance of the entire fender to basically where it's going to sweep out. So if you run a flat piece from here all the way up, that is going to show you where you need to make your panel alignments and adjustments to be flush. We're setting these gaps to 3/16. I'm just using one of the Big Kid gap tools. And although they work good when they're brand new because you can scribe, I'm just using this to give me a consistent gap. You could use 3/16 brake line, whatever works. Just grind the edge away. These are Clecos that I use to pin the exterior panel to the interior panel, because otherwise things will start moving on you. But the nice part here is we have our gap consistent all the way through. Even up here where we've met the windshield frame, we have gap. And then this is the one that we're gonna have to add. You can see here, we've got a good almost 1/2 inch. So if we add 3/16 to the edge of this door, that should give us really close to the gap that we need. And we're gonna basically take the fender off next, keeping in mind if you have any spacers, what spacers go where do things realign to. I'm going to be putting tape around the hinges once the fender is off so I can make sure that I put this door right back in the same spot. Another thing that makes it easier is if you have a door that is gapped or any panel that's gapped, when you go to put the car back together, you can look at one side of it and actually be able to see if things are aligning. Where if you didn't have a consistent gap through here and you're trying to align the door up and down, you wouldn't know what's right and what's wrong. If you set it in the metal to where you get the edge perfect, then you know that just has to be exactly flush with the gap that you set. the fender off. Now what we want to do is we want to use some brake cleaner and just clean up around the area where the hinges are. So that way we can mark exactly around these hinges with a Sharpie, and we can put this door right back in the exact same spot. Now later on we'll be drilling these with 1/8 inch holes, so you have an alignment pin to put these hinges back where they need to be. We'll be doing this on the body side as well as the door side, but we don't typically like to do the holes until we are all the way done with body work. We've done all of our high build primer and blocking things together. I like to make sure we drill things last. So at least this just gives you a placeholder to be able to come in and put everything right back where it was. You can also put tape around these or both. Now that I've got the door off the vehicle, went ahead and marked around each one of the hinges, so that way we don't lose the exact position and orientation from each hinge. You need both hinges to be pivoting in the same plane and not offset from one another, because it's going to make the door open and shut a lot more difficult. What we did was we set the door in the car initially so we knew exactly where it had to be, pretty close within reason, and then we put the hinges in very carefully in unison to make sure that they're aligned as best as we can. Now that we've made a scribed piece of template that we can then transfer over, we want to maintain the thickness of the door edge. And so in order to do that, we're going to be using a piece of 14 gauge sheet metal that we're going to trace, and we're just going to cut out the side profile of the door. You could do this with a kick shrinker or stretcher to get it to go around the door perfectly. And if you don't have that, which we do, but in this case, we're just gonna use a template and cut it out in the exact shape that we need. It will save time. And then at that point, we're going to weld this along the edge on both sides with the TIG welder. We're going to use the TIG welder because it's a lot softer of a weld. We will be able to remove a lot of the warpage that happens. What typically happens when you gap a door, and if you're using it MIG or TIG, it doesn't really matter, the edge of the door will actually curl in. And most guys don't see it to be a problem until they get to the bodywork phase. And what needs to happen is when you start putting a straight edge down the side of the car, you start noticing that there's excess filler right at the edge of the door. And a lot of times it might only be an inch in from the edge. We're gonna show you guys how to remove that later in this video. But the next order of business, we're gonna get this cut out. We're gonna get it tacked in because we're adding to the front of the door. We've already ground the back of the door and we have everything clamped in place so nothing can move. And then at that point, we will start welding every edge. We're gonna add a little bit to the bottom with some TIG rod, and we're going to just be welding the pieces together on the back side, as well as making this flange so that way it looks like the door is folded over, when in reality it's going to be 3 pieces. The outer skin, the door structure in the middle, and then also a flange that will lay in the inside. When it's all said and done, this will look factory and you will have the fit and finish that you need. I've gotten the additional piece all cut. I've just kind of hand bent this into the shape of the door. I've got my TIG welder out and ready. And what I was just doing was measuring the thickness of the door edge. Now, this is 14 gauge, and That equivalates to about 70 thousandths of an inch. The edge of the door, with all 3 layers there, we're at about 120 thousandths. We don't want the edge of the door to look false, and we want it to look as if it was not modified. So what we're gonna do, because this is thicker than this piece and we want to end up at the same look that we have here, we like the way that you have this 1/2 inch flange where the door edge has been folded over. So what I'm gonna do is I'm gonna take the 14 gauge, I'm gonna cut another piece out with the same templating method, but I'm gonna cut a piece of 18 gauge. And what that's gonna do is, between the thickness of the 70 thou and 45 thousandths for the 18 gauge, it gives me the exact same thickness as what we have right here. So the next thing I'll do, I'm gonna grind this flange off, and the door is going to split apart, because then all you will have left is the structure and the outer. And then what we'll do is we'll come back, I will tack weld this to this edge like so, and I'll just tack it and get it to align with the door. We've already got it really close. And then at that point, I'll weld this seam all the way through without this flange on it. And then at the end, I will sandwich the 2 back together, so that way you have the same flanged look and it will look seamless. Guys in here closer so you can see what I've done. I've basically eliminated the lip that you see here, only on the side that we are going to lengthen. Now I've got a set of calipers here so you guys can see we are really close. Oh, right there, 70 thousandths of an inch. So if I've got 70, between 70 and 80 thou here, and then up here on this piece of 14 gauge, you can see we're really close. This does not have to be exact. I'm just giving you guys a demonstration that what we want to do here is take the skin of the door and the structure, and we're matching that thickness to extend it. We're making it a little bit longer, so I think we have roughly 1/2 inch, but really we only need to extend the door about 3/16. So what we're gonna do, we're gonna come in, now that we've got that ground out of there, we're going to place in our additional piece here. It's hard to do with one hand. I'm going to use magnets to hold it in place. We're going to tack this and weld this all in, and then after it's welded and ground solid, the door will no longer split, because this is getting welded when we extend this. And what that's going to do is make it the seam strong. And at the very end, we will make a piece that sits in here, and we'll weld along the edge, and it will look exactly as what we started with up here. When you start to tack weld this flange into place, everywhere that you tack weld, doesn't matter whether you start in the middle or you start on one end, as you tack weld, it's going to shrink the very edge of this piece. And what you're gonna find is that when you had it up there before you welded it, it may have fit perfect. But every single time that you weld, it's shrinking that edge, and it's going to pull this flange inward to the door. So the way that you combat that to keep this in line with where you want to go is you use hammer and dolly work. When you're taking this, you want to be smashing the weld itself. So it shrinks when it gets hot and you weld it, it expands, and as it cools, it shrinks and it pulls in. So you have to take that ball of shrink that the weld is and then smash it back out, and what that will do is keep this in alignment. Now, if you hit this too hard, you'll bring this too far out. So you need to be watching to see what you need as you weld something. Sometimes it could be 1 tack weld, and sometimes it could be after 5 tack welds. Some patch panels require more hammer and dolly work. So if you just keep things relaxed, and it really doesn't take much hammer and dolly work, a lot of times just a couple strikes like that will stretch the weld back out, and then that piece will fit nice. As I'm going through the body line here and a body line down below, I will tack right up to it, and I'll just keep moving this piece up and down. Well, when it's hot and you've tack welded it, you can bend it really easy to go with the flow of the door, and just tack it as you go, hammer and dolly it as you go, and you shouldn't have any fitment problems. Flip the door over, and we're going to weld the front side of this 1/2 inch flange that we've now added. We've done hammer and dolly work to make sure that this is dead flat. And then what you want to do, because we've measured this, and right now we're at 70 thousandths. When it comes to the TIG welder, you want to be setting your amperage accordingly. So for every 1/1000th of an inch, you're going to set it to 1 amp is the baseline that you want to start at. So 70 amps would be ideal, but sometimes you need just a little bit more amps to balance back and forth as you weld this. And if you have areas that are thicker, that might require those extra 10 amps. So do what works for you, but for me, if this is 70, I'm going to set it about 10 to 15 amps higher, and you're going to be using a foot pedal typically to fluctuate the amps as you go through this. Now, I'm going to make sure that we have every 1/2 inch tack welded before we actually go through this. So through here would work just fine, but these areas over here where we have bigger spans, when you go to continuous weld it from one end to the other, these gaps will start to move and become uneven, and it's hard to come back from. So the best way is to come in here and close up these gaps and tack weld everything, hammer and dolly it all, finish it out, get it all straight, and then when everything is locked, you can come through and continuous weld it all the way through. The filler rod we're going to be using is ER70S2. This rod that we're going to use is 60 thousandths. The reason that's going to work nice is because if you have 70 thousandths as your material you're welding, and you have a filler rod that is slightly thinner, it's going to melt in a lot easier, and you're not going to be struggling trying to get that to weld. Now, if we were doing just the exterior, where this might be 40 thou, give or take, then I'll be using a rod that's 30 thousandths, so that way it's melting faster than what the parent metal is. So I'm going to put this on time lapse for you guys, and we're going to go ahead and weld this baby out. extended it a 1/2 inch, even though we only need probably 3/16. That will allow us to put the door and the fender back on the car, grind it exactly to where we need it. But before we put the door back on, I need just a little bit of length on the bottom of the door. We're going to be using 1/8 inch TIG rod because I don't need as much as the front, just enough to be able to grind it back to have a 3/16 gap. I'm not going to show this process because it's exactly the same as the front of the door, except for using a round 1/8 inch rod. We're just going to place it along the bottom, tack weld it in alignment with the edge of the door as we go, every 1/2 inch, same as the front, and then weld it out. Once we get everything extended as far as we need, we will then be going back to the car to mount all of this back into place. All of our final grinds will be made, and then we will take it back off for a final time to add all of our inner flanges on the back of the door and the front of the door. As far as the bottom goes, because we're only lengthening it such a little bit, we're going to leave the existing flange that is on there, and we will not have to make the modifications to the back side of the flange at the bottom. Now that we have door is on, fender is on, you can see here we added this 1/2 inch. We only needed like 3/16 of an inch to be able to create our perfect gap. I can't even get the fender all the way back as far as it needs to be. Right here we have a fingers gap. So what I'm gonna do is I'm gonna just use 1/2 inch green tape to be able to follow this, so that way I can scoot the fender forward slightly, come in and rough out with 36 grit with a 3-inch roll lock. And I'm also using a smaller backing plate on the roll lock. That way, when I do get close to the gap that I need, I can come in and just stick the disc in between the gap and slowly bring that to the distance that I need between the door and the fender. At this point, we're just gonna slide the fender forward once I make my tape line, rough it in, and then I'll bolt the fender exactly where it needs to be before we finalize this gap. Right now we have the back of the door has already been welded, flanged. The bottom of the door we added the TIG rod to. It is really close, so we'll be doing some final grinding. And then the only thing I'll have left is to put the inner flange onto the front of the door after we pull it back apart again. Now that we've got the door gapped, we've extended this edge previously, we ground it, and now we have it off of the car. So you can see where this is the structure. This is the outer skin that we have lengthened. And so you can see what's last bit of that little bit of TIG weld inside of there, which we don't care about at this moment because what we're gonna do is tidy up the inner portions of the door jamb at this point. So here you can see the original lip from the other door skin and the new one. So what we'll do when we TIG weld this is we'll come in and we will weld that together. I'm going to shear off a 1/2 inch piece of 18 gauge. So that way it matches the bottom flange here. I will then overlap it, covering where you have the structure and the skin, and we will make it look like it was the original skin folded back over and look seamless. So what we'll do is we will clamp it. We will use the kick shrinker stretcher. I'll show that process and how we get it to curve and conform to the edge of this door. Once we do that, we'll clamp it in place and we will weld the edge of it and show you guys that process. What we've done is we have sheared off a 1/2 inch piece of 18 gauge, and we kept the template from the very beginning where we made the extension of the front of this door. Instead of me having to go back and forth between the shrinker and the stretcher, I have this profile that I can just hold with it while we do the adjustments to this piece. So you can see here, there's quite a big difference. And it's got just a slight curve in this panel up in this area, and it's got a pretty drastic curve here in the middle. So what we're going to do is we are going to use the shrinker when we're going to shrink one edge, and that's going to get it to start bowing. If we overwork it too far, that's why I have two to go back to the stretcher and just work it back the other direction. If you didn't have two, it's not a big deal. They have extra jaws that come with these, and it's just not really cost effective from somebody who's doing it every day as a job versus somebody maybe in your garage. But switching these jaws back and forth became monotonous, so I bought two shrinker stretchers. That way we could be efficient. So what we're going to do here, we're just going to make sure we have the overall length where we have excess. And so what I'm going to do is I'm just going to start in one area, and we're going to shrink one edge. This is a foot operated shrinker, and you can see right there we're already getting what we need. So we will just keep watching this and hitting each little spot to get it to go in the direction that we want it to go. Now, when we actually match up the bottom, you can see that now it needs to go the other direction. So now what we're going to do is we're going to stretch on this edge, and that is going to bring this back down the other way. I'm going to be watching for the light coming through, so I'm going to match this up. And for the demonstration of this video, I don't have enough hands. I would typically make a little Sharpie mark as to what area is good and what area needs to start bending. So if I have it touching up to this point, I'm going to put that specific center right in the stretcher, and now I can watch it start to go the other direction. And that one did not take much at all. It's nice too when you clamp it in, then I have the ability to sit here and freely move the cardboard back and forth and check where it needs to start curving the other direction. A lot of times it does not take much pressure at all to get this to curve where you need it. Very light pressure, small movements at a time. And right there we already have a really nice curve. You can see now it's starting to go back the other direction. There you have it, just that fast. We already have one whole side that fits 100% perfect. Now we'll go ahead and do the other side. I'm going to do here is now match this up. This door is going to curve like such, so I'm just going to put small bends so that way it will lay in here really nice. I'm going to line up the very farthest edge, and then I'm going to make some Sharpie marks to trim off my edges, and then we will edge weld this, and you will see that this now looks like a factory door folded over flange, when in fact we've done a pretty extensive a bit of adding and subtracting to door edges, but we're still keeping that factory seamless look. Tacked in every ½ inch, so that way the edge as you weld it cannot open up and move. You're locking that piece in so that way when you continuously weld it, it's not going to separate and have an edge that becomes thicker and smaller and so forth. The other thing that happens is if you're shrinking this edge by tack welding, the panel will start to do even more panel dive. Well, what is panel dive? Panel dive is the crown of the center of the door, and as it swoops in at the fender and swoops in at your quarter panel, the way that you remove a lot of that panel dive is to hammer and dolly these edges back out flat. The best way to do that is off the car. Using a straight edge, you can actually see it's a good ½ inch dipping in and about 4 inches into the door, 3 to 4 inches. So if you have a few inches in at the last bit where it crowns in, it's already starting to do that with every tack. The reason that it's going inward is because it's going to take the path of least resistance. Your door already has some level of crown in it, so when you shrink the edge, it then does what I call turtle shelling, and then it curls over even more. The way that we reverse that is we use a toe dolly on the exterior. It's a little bit of a challenge to hold the door, but if you can wrap it around or clamp it to a table, you put that flat edge, you can see the distance that it has to move. Every one of those tack welds you want to smash and correct it back out to the exterior side. We've already done that on the front, and now at the front of the door up here above the body line, we already have it dead flat. We check that as we hammer and dolly it and keep stretching and working that edge back out so it's flat. This is not going to correct the entire crown of the door. It's only going to correct what welding you're about to do. We've only tacked it and it's already started to curl. So now we just want to correct it back before we continuous weld it. Otherwise we'll have even more shrink that we'll have to work back out. The other thing we did was after we tack welded it, we ground everything dead flat back to the original edge. You don't want every one of those tack welds because we want a nice smooth edge to grind. We don't want humps in the weld. We want it to look like that perfect stacked dime caterpillar along the edge of the door so it's easier to grind. Otherwise, if it has all those bumps, it's going to take you a lot more effort to make the edge of that door look back to flat and be gapped back to the fender. bit, go all the way through, and then check it. You can see up here where we've already done, it's already flat. Here it's better, but it's still not meeting up with the edge of our straight edge, so we're going to keep working it. It's better to do a little bit at a time and check it, otherwise you'll end up with this door curled out above the flatness of the door. We just want to correct what has shrank. Is not to just take the hammer and push it back out. The initial, you need to actually stretch it. I can't emphasize that enough. If you're not actually stretching out that ball where the tack weld is, it's not going to relax enough to then fold back straight. So it's a learning curve on understanding how much you have to smash that to get it back before you have curled the door over too far and then have to bring it back, and it causes a whole bunch more damage than you would want. Along the edge is because if you were not taking out that curl when you body work panel to panel, the edge of the door ends up excessively thick. Depending on whether the door swings inward or outward, it may hit the fender, and so in order to get the most clearance that you need both the fender and the door aligned as perfect as possible. So at this point we have everything flat. We have everything tacked a 1/2 inch, and now I'm going to come back with, I'm going to use 060 60 thousandths of an inch filler rod, because I want enough filler rod on there that I'm not going to be burning down into the door skin itself. But I also want to be playing with what size filler rod with how many amps. Typically you match your sheet metal with the thickness with your amperage. So let's just say it's 053 or something like that for thickness, then you would set it to 53 amps. Now in this case, we're gonna play with the amps a little bit more because I've already measured this with a set of calipers, and we have about 110 thousandths on that edge. We want a nice round weld bead so that way the edge of the door looks nice and round and not so square. Obviously we're going to grind it and that will square it up, but we'll have to DA it back round. We're just trying to minimize how much grinding you have to do. The other thing about TIG welding is it's extremely softer than a typical MIG weld would be. Can you do this with a MIG welder? Yes, you can, but you're more susceptible to having a brittle, cracking edge, because what you end up doing is grinding down the bulk of that MIG welded edge, and what you're left with is not that much penetration. And because it's harder and it's such thin sheet metal, you figure you have three different pieces. You have the exterior skin, the door structure itself, and then you have the flange on the inside. We want to penetrate all three of those perfectly. So if I have 110 thousandths thickness here between all three of those, I'm going to be in the range between 100 and 120 amps to melt that in. Now I'm going to be playing with a few different settings. I'm actually going to go lower to about 90 amps, and what that's going to allow me to do is just take my time and feed that in there nice and slow. The more that you can do for your ability while you TIG weld to go straight through versus doing small sections, you're going to have small waves in your TIG weld. That goes for a butt joint on a typical patch panel on the exterior, and it also goes for these edges. It will make the edge look like a whoop section. So if you can hammer and dolly the tack welds back flat, and then you have a nice flat edge that you're welding on, you don't have the speed bumps, you're going to get a nice continuous edge. We're going to play with the amps as we go, and we'll talk about, after we get it welded, what we actually ended up with, so that way it's repeatable. I'll also make notes for if I'm doing a door edge. I will notate how thick the door edge is, what amperage did I use, what filler rod did I use. That way every time I have a reference guide that I can look at. It's going to be different for a patch panel and different for different thicknesses of sheet metal. So you're always thinking about what is causing that weld to be excessive, what's causing too much penetration on the backside. You want to dial it in right where you need it, where you have perfect penetration with as little warpage and shrink that happens. No matter who you are, you're going to get shrinkage from your welding. It's not going to be perfect, and you're going to have some level of warpage. It's understanding how to reverse that warpage that is key. This is fully welded out. We've already done some hammer and dolly work to get this back straight. And now all we have to do is face the welds on this side, a little tiny bit on this side, and then we'll put it back in the car. You can leave this jagged edge and we will finish the final grind and the final gap in place against the fender on the car. Back on the car for the final time. We've already gapped the bottom, the backside previously in the video, and as you remember, we just did the final weld on the front of the fender. The front of the fender was the side that we had to extend. So right now it's slightly longer because of the TIG weld along the edge. Already faced both the inner side and the outer side. It's all tidied up. But what we're most important looking for here is flatness. You can't just jump to splining and body working this thing flat before you focus on your door edge itself. What I will tell you is if you take a 12-inch ruler and you were to stick it between the two, it might look pretty close. But you need to be using something along the lines of a spline that's almost 3 feet long and checking the curvature of the whole panel. Better than a spline would be either a piece of flat bar, or we use really thin wall 1-inch aluminum round stock. What this is doing is it's going to create the shape that you need. So what shape do we have on a 67 Nova? Every car sweeps in slightly in front of the wheels and in back of the wheels. Almost never are they ever dead flat. But the areas that we do gotta get dead flat is from the center of the wheel here to right behind the door. From the quarter panel, it slightly flares out, and we want that natural curvature in the reflection when we're done. So in order to check that, we use the round stock to just have a visual, again, from the very back of the door, only about a 1/4 inch into the quarter panel, and now you have a visual. If you have a curved car, you can get 2 people and put them on either end. But right now, when we sight in, we have massaged the edge of the door to be 100% flush within a 1/16, so you don't have excessive filler buildup on the edge of the door. If you were to leave it without stretching the edge out, when you open the door, it chunks the filler off, and then you end up with this vicious cycle fighting back and forth to get the filler straight and have clearance. So making sure every panel is in alignment with one another is key while maintaining your gaps. The only thing we have left to do is we are going to take a die grinder with a 36 and an 80 grit. I'm gonna put an 80 grit on here because we don't have very much to remove. We only have a very small TIG weld to just finesse in, and we're also going to be using our gap tool. This gap tool is made by Big Kid Blocks. We've talked about them in past videos. The only thing that I don't like about these is, although they say they're hardened, they wear out extremely fast. I don't believe that they're hardened, in my opinion, but they work great because one edge is gonna ride on the fender side, the other edge of it is going to scribe your line, or in a lot of times when they wear out like this one, I just use it for a visual guide to be grinding down as I go to fit that gap tool in the edge. At that point, we've already gapped it, we've welded it to the gapped area, and so that last little bit, hopefully your door does not split to where you have to grind off that much. And that's what's nice about TIG welding, is you don't have an excessive amount of buildup on the weld. The goal when you get done with doing all of your body filler, your polyester or VP 2050, when you're coating the car in primer, I'll flip the camera over here and just give you guys a real quick visual with that 1-inch aluminum pipe. Swing you over. Here, we can do a quick check of perfect panel alignment. This is in the polyester stage, and we're just verifying that we don't have any discrepancies or inconsistencies in the mirror that we are creating in our finish. Hope this video helped you guys on just dialing in some of the little nuances of making a car the shape that it needs to be, nice and flat, and not dealing with something that has too much crown. Panel dive seems to be the biggest issue across the board that a lot of people don't necessarily talk about, and I think it's because every car has a different issue. The majority of the panel crown and panel dive is where the door crowns in slightly on either edge, and you have to work out the edges without creating massive lows. And in some cases, depending on what level you're building that car out, you may have to remake the lower section of the door, especially if you're working with aftermarket panels. Aftermarket panels typically have more crown than they ever had from the factory. Most of the factory OEM stuff that we deal with on the regular has enough panel dive that you can just work out the edges slightly and everything tracks nice and flat. So sometimes don't toss your original fenders, keep them until the very end, because sometimes you have to put them back on and deal with whatever issue that factory panel had. I hope this video helped you guys, and we'll see you on the next one.